formula. x2 minus x1, everything squared, plus y2 minus y1, everything squared. I will label my points. So I recommend x1, y1, x2, or x sub 2, y sub 2. And then plug them in. So I copy the square root of 5 here. I meant the square root, negative the square root of 2. That's what I meant. Okay, minus x sub 1, which is 4 the square root of 2. I copy y2, which is 5 the square root of 5, and I copy the square root of 5. If you like the method, please use it. If you have a different one, please use a different one. So now, negative the square root of 2 minus 4 the square root of 2 is negative 5 the square root of 2, which will be eventually squared, and we will get a positive number, mandatory, plus 5 the square root of 5 minus 1 the square root of 5. It will be 4 the square root of 5, and we have to square it. Is this okay so far? Yes?
I understand how you got the 2 because they were both the same. So how did you get the 5? So that's kind of like a 1 in the beginning. Okay.
So it's negative the square root of 2 minus 4 the square root of 2. It's like saying negative an apple minus 4 apples is negative 5 apples.
Okay.
Is that better?
Yeah.
Because I have negative 1 the square root of 2 minus 4 the square root of 2. And that's how we get the negative 5. Better?
Yeah.
Then here we have 5 the square root of 5, but minus 1 square root of 5, which would give us 4 the square root of 5. Better? Okay, so now I have to square both factors. Negative 5 squared is 25. The square root of 2 squared is 2, plus 4 squared, which is 16. The square root of 5 squared, which is 5. So then the distance will be the square root of 50 plus 30, 80. So then the square root of d is the square root of 130. And there is nothing we can do about it. But they're also asking us to approximate it. So in order to approximate, I will put in the graphing calculator, and I will approximate it. So I have the square root of 130. And I get approximately 11.402. I don't know how many digits they want, so 402. Any questions? Was this the only one, Cece, or did you have something else? I don't remember. Yes? Ready?
Going back to the combination.
Okay, f of x and g of x.
The only ones I couldn't get was the middle part where
Finding the domain of function composition.
I couldn't get b.
Okay, what is f of x?
The b, yeah, the f of x.
So what is f? We need the function f, so we can work with it.
Oh, f is 3x minus 4.
And g?
It is 5x squared minus 4.
So one more time, 3x minus 4 and 5x squared minus 4.
Correct.
What are we asked to find?
You asked to find a f of g.
So f comp g of x, which is f of g of x. And we don't need this one because that's done correctly, correct?
Yeah.
Okay, part B.
So b is g of f.
Okay, so we are looking at the other one, g of f of x, correct?
Correct.
So first of all, you don't have to cross it out like that. I'm making a point. This is 3x minus 4, so I have g of 3x minus 4, correct?
Correct.
Good. I'm looking at g now. If this now is 3x minus 4, this will be 3x minus 4. So let's continue. So therefore, I have g of 3x minus 4. I'm going to write it one more time. So this is 5, 3x minus 4 squared minus 4. I don't know what the error is, so that's not important. But if you or someone, when you square this, you do not get three terms, like 9x squared minus 2 times the first times the second plus the second term squared, then that will be wrong. If that's the case, I don't know, I can't say, right? So then you have 5, 9x squared minus 6x plus 16 minus 4. That's why we did this, in case that's the question, on the first day of classes. So this is a squared plus or minus 2ab plus b squared. If this is minus, then this will be minus. So the first term squared minus 2 times the first times the second. 2 times 3 is 6. 6 times 4 is 24. I talk too much. 24 plus 16 plus the second term squared. Okay, so then we have 5 times 9, 45 x squared minus 5 times 24, 120x, and plus 80 and minus 4. So the final answer is 45x squared minus 120x and plus 76. Is this okay?
You actually did it a little bit too fast.
Oh, which part is not clear? So this is the square, and then I have to distribute 5. So when I square this, I get this. Is that okay?
Right. Okay.
And then I just distribute it.
Okay.
I just copied it one more time.
Okay.
Is this clear?
Yeah.
Good. Is there anything else that we need to look at? Anything else that we need to look at?
I have one.
Yes, please.
It's
Is that good enough, Cece?
good.
Okay, perfect. Did you have anything else?
No.
Okay, yes.
12.
Yes?
Square root. 12 square root x. I forgot. What
Oh, 12 the square root of x?
Yes. And it's a 1-to-1.
So this is f of x?
Yes, that's right.
Okay.
And then it says the final.
Is it the 12th root of x?
Yeah, 12.
Oh, okay. No problem.
And it's, so the first part was find the inverse.
Good. We found the inverse, or we need help with that?
No, that was fine. It was just the f of the. I don't know how to say it. I don't know.
F of f inverse?
Yeah, f of f.
Right. So remember, when we determine the inverse function, in this case, you will have y equals the 12th root of x, right? So remember, here x must be greater than or equal to 0. Mandatory. Otherwise, I cannot take an even root from anything if this quantity, whatever that is not greater than or equal to 0. That's mandatory. So the 12th root of x, so the function f, is defined on 0 to infinity. And if you graph it, you will see it has 0 to infinity as well, because it's a square root, like, or the 12th root. So when I find the inverse function, these will be reversed. Well, it happens that they are the same. So now I can find the inverse function. I replace f by y, and I take both sides to the 12th power. So y to the 12th is x. And of course, we have to replace y equals x to the 12th power, because we have to interchange them, right? So f inverse of x is x to the 12th. But x to the 12th has no restrictions. But I have to impose this restriction, because like with x squared is not 1-to-1. X squared doesn't have an inverse function. But this piece of x squared does. The same thing here. So that's why this is greater than or equal to 0. Although you can say, wait a minute, x to the 12th exists for everything. True. But the entire function is not 1-to-1.
Okay, I think I got confused because the answer I had.
We are not done.
Okay.
So now, when I determine f comp f inverse, or determine f inverse comp f of x, I have to get x, because they are inverses of each other. So the problem is asking you, fill in the gaps. So you have to fill in with the f inverse here, and you have to fill in with f here, with the function, the original function here. And the answer must be x on both sides. So you have to put x in there. And how do you show that? So which one would you like to show? So let me summarize. We have f of x, which is the 12th root of x. We now know its f inverse is x to the 12th. It happens that both functions are defined for these values only. So now, would you like to check f comp f inverse? Or would you like to check f inverse comp f of x? Which one?
We could do F inverse comp.
This one. Very good. So this is f inverse of, I plug in f, which is the 12th root of x. And now I look at this. F inverse is blah to the 12th power. But this is my blah. So it must be x. Otherwise, what I determined makes no sense. So copy the base, right? So, or raise this to the 12th power. This is power 1 over 12, right? So this is x to 1 over 12, everything to the 12th power, and you get x. It must be. Once we determine the inverse function and it's correct, the answer of f inverse comp f or f comp f inverse must be x, because they are inverses of each other. I determined the inverse. But now if I made an error, then I will not get x. Is this better?
Yeah, I just didn't understand how the X, because I got partial credit, but for this part I didn't.
Yeah. So once I determine the inverse function and it is correct, any composition in any direction, f comp f inverse or f inverse comp f must be x. It's like the silly example, I'm giving you $10 and 5 minutes later I say, give it back to me. These are operations that are inverses of each other. So adding 10 and subtracting 10, nothing happened to x. My pleasure. Anything else that we need to discuss? Yes, please.
I have one more.
Yes, go ahead.
If you got 6.99, that's more of a word problem.
2.6.9. Yes,
99.
99. Okay.
And it's a word problem, so I don't know how you
Okay. Is it something you send me?
I think I did. Let me send it to you now.
Yeah. If you send it to me now, it's even better, so I don't have to look for it.
I just sent it.
Got it. Technology. Okay. So yeah. So this is, I send you any information on this one. Okay. Yeah. You in your email. So that's fine. So a company sells radios. Has yearly fixed cost of $550,000. It costs the company $50 to produce each radio. So revenue is $50 times x. So revenue, R of x, is $50 that we get for selling each times the number of units we sell. Then the company, so the cost of x are fixed plus variable. Is this okay so far? Any questions? Okay, so then C of x is a function. The fixed costs are given to us, 550,000. Plus, it says the variable, the company's cost and revenue are modeled by the following. X represents the number of radios, so they say, oh, the revenue is 75, I'm sorry. 75x, and this is 50x. So the revenue is 75 times x. So the two functions are given to us. We don't have to reinvent them. So now they're asking us to find and interpret R minus C of 11,000. Is it 11,000? Yes. Then R minus C of 22,000 and R minus C of 33,000. So let's do just one of them because they will be the same. Is that okay if we do one of them? Okay. So when we add and subtract functions, like in this case, 2, 3, 4. Okay, so this is R of 11,000 minus C of 11,000. what I would have done, R minus C is nothing else but the profit. So the profit of X is revenue minus cost. I will have determined, this is my preference, I will determine the function R minus C. R of X is 75X, and I subtract this function, minus 50X and minus 550. Is this okay so far? I'm just creating the function revenue minus cost, which is the profit function. Is that okay?
Why'd you change it to minus?
I'm subtracting. When I subtract, I have to subtract everything.
Subtract everything, like change the sign.
I have to. It's minus in front of a function. Minus in front of any term will change.
Oh yeah, okay.
I have to subtract, right? From the revenue, I have to subtract all costs in order to get the profit. So this will be 25X minus 550,000. All I have to do now in this function of profit, I plug in 11,000. So I will have 25 times 11,000 minus 550,000, whatever that is. And for the other two, that's the reason why I wanted to create the function, because for the other two, I just plug in what I'm given. I don't start from scratch. I don't start by reinventing the wheel from the beginning. So when I calculate this, what is it? What is 25? 25 times 11,000 minus 550,000. So negative 275,000. What does negative 275,000 means? A loss. They're losing money. What if the answer is 0? They're breaking even. They're not losing and they're not making money. What if the result is a positive number? They make a profit. Is this good enough? Is it better? So the reason I looked at the other questions and I said to myself, okay, why don't I just create the function? Also, you can put the function in the graphing calculator. That would be the nicest thing to do. Like in y equals, you will put in 25x minus 550,000. And then I have to go back here. I'm sorry, I have to change this. No, that's not what I meant. I have to change this into the ask mode so I can ask whatever I want. So the problem is asking us 11,000. And I get the answer. What was the second question? The second question, 22 and 33. So 22,000. That's why it's so much better to put in aha and 33,000. So that's the easiest thing to do, to create the function, put in the graphing calculator, and not repeat the calculations 3 times. We just plug it in. So the first one is a total loss, right? A lot of money. The second one is a break-even point, and the third one, they make money. $275,000 profit, net profit, after removing, taking away all the costs, fixed and variable. This is what I recommend. Any questions? Any questions? Okay, perfect then. So let's go back then to our function from last time that we did not finish. Very good questions. Thank you. So the function was, you don't have to copy the function one more time. You just, or do whatever you want. So I'm copying it. So f of x equals negative x squared minus 4x minus 3. So we are asked to graph this function, and we have to go through 8 steps. Those steps, as I said, they will be mentioned in the test. Okay? On the test, you are going to have all those mentioned. Okay. So here's the first step, domain.
So we do this all over?
Yes, because I didn't finish it last time, and I don't want to just start right in the middle. You don't have to copy the whole thing.
It's already, I'm just going to start from, I have everything copied.
Okay, very good. So the domain, negative infinity to infinity. Why? Because this is a polynomial function. It's quadratic. It has no restrictions whatsoever. Step number 2, the shape. We know that the quadratic function can open upward or can open downward. This one will have a minimum, and this one will have a maximum. The minimum is always when the leading coefficient is positive. How do I know? Well, from transformations, right? When we graphed x squared, positive x squared, did it have a minimum or a maximum?
Positive x squared.
Did it have a minimum or a maximum?
Maximum.
Right, minimum, right? And if I multiply this by -1, and the leading coefficient is -1 x squared, then we will have a,
Oh, that's not it.
right. So when the leading coefficient for the quadratic function is positive, minimum. When it's negative, maximum. In this case, because the leading coefficient is -1, this is our case. Yes, not this. So it has a maximum. In the next step, we have to find the vertex. So that maximum is also called vertex. And the minimum is also called vertex. So we are looking for number 3, vertex. The vertex has a y, an x coordinate and a y coordinate. But now how do I determine the x coordinate of the vertex? When the function is given like this to us, we have to determine the vertex by finding -b over 2a. And I was saying last time that -b over 2a for easy memorization, it comes from the quadratic formula. It's everything except the plus or minus the square root. So negative, b is -4, 2 times a is -2. All this gives us a -2, and I have to put it in the vertex as -2 for the x coordinate. Then for the y coordinate of the vertex, I have to do what?
Excellent.
Exactly, plug it in. Excellent. So then I have negative outside, -2 squared, -4 times -2 and -3. So notice that I didn't do anything. I just replaced x by -2 all the way. But now I have to perform the operations in the order of operations. I have to be very careful. So -2 squared is 4, but with minus in front will be -4. This product, -4 times -2, is +8 and then -3. So the answer is 1. So we determine the vertex that's -2, 1. Any questions so far?
Let's have one.
Please.
I know you already
please.
said it, but
I want to say it again.
the -b over 2a
Yes?
comes from what now?
Remember,
From
perfect. So we have to remember the quadratic formula no matter what. So I'm trying to connect the quadratic formula to the x-coordinate of the vertex so you remember it in the long run.
and the quadratic formula is the
-b plus or minus the square root of b squared minus 4ac over 2a. If you remove everything and you just leave -b over 2a, that's the x-coordinate of the vertex. So let me write it.
No matter what the problem is, we have to do the -b over 2a.
For the x-coordinate
the
of the
x.
vertex. Exactly. So that's what I was saying last time, is -b over 2a, the square root of b squared minus 4ac divided by 2a. This we have to memorize, right? Why don't we connect it to this and say, oh, -b over 2a is the x-coordinate of the vertex. Since you still have to memorize the quadratic formula, why not connect it and say, oh, -b over 2a is the x-coordinate of the vertex.
Oh, that. Okay. You talk a little fast. Okay.
That's why I would like to repeat it.
All right.
Anytime you want me to repeat something.
And that's the quadratic.
This is the quadratic formula, which we'll have to remember anyway, right?
Right.
We had to remember it for the previous test and for the final. So I said, okay, maybe it's easier for my students to understand where this is coming from by remembering the quadratic formula. So now is it clear how we got the vertex? Yes? Perfect. Good. Step number 4. X, bless you, X-intercepts, and we said if they exist. So how do I know whether they exist? Because I don't want to waste my time. It's on high 1, so sorry.
Well, we found the x-coordinate, so wouldn't it be?
So how do we find the X-intercepts? For any function, not just for this one. Always, forever. X-intercepts. We set
Oh, we said it.
y equal to 0. But I was saying last time, I don't want to waste my time. Because if this equation has no real solutions, I will be spending a lot of time using the quadratic formula on this. And I don't want to. So let's establish from the very beginning if this equation has solutions or not. So remember we said that the function has a maximum, correct? Okay. So can anyone give us the coordinates of the vertex for the maximum?
0, -1.
Coordinates of the vertex.
-2, 1.
-2, 1. So if the quadratic function has a maximum that is negative, it will not cross the x-axis. If it has a maximum that is 0, it will touch the x-axis. But if it has a maximum that is a positive number, it will cross the x-axis twice. Which case is this? Is the maximum negative? Is the maximum 0? Or is the maximum positive? Maximum value. The maximum value has nothing to do with x. X tells us where the maximum will be found. The y value will always tell us
It's a positive negative.
exactly. Is that clear?
Could you like write
Yes.
that down or something?
Yes. So that's why I was giving those 3 possibilities. So this is one possibility. Max is negative. It's whatever this number is for the y-axis, for the y value. Here, maximum is 0. Max is 0. And here's the third situation in which max is positive. Since the vertex in our case is -2, 1, which of these 3 situations has a maximum that is a positive number? Not this, not this, but this. So the quadratic function will have 2 solutions. The quadratic equation will have 2 solutions, and the quadratic function will have 2 x-intercepts. So I have to find them. In this case, I will not waste my time. In this case, it must be 0. Right? It has to be the vertex. In this case, I don't have to waste my time at all. This is the vertex. But this number is not 0, so it's not this situation. So I'm looking at this one. So I have to do the work because it's the third situation. Is this better?
So if that number was,
If I have -2, -5 is this situation. If I have -2, 0 is this situation. If I have -2, a positive number, it must be this situation.
but you, okay.
This one here
I
is
get that part. I'm talking about the y. So you equal y to 0 to get the x.
to get these 2 points. But we haven't done that yet.
So what are we doing right now? We already found the vertex, right? That was called,
Right,
which is -2 and 1.
comma 1, which gives us this is the maximum value of the function.
Okay.
So it's not this situation. It's not this situation.
So y actually equals 1 then, right? Or no?
Yes, correct.
So why does it say y equals 0? That's what I'm confused about.
Here,
Yeah. No, up on top of it.
but that's how we determine these points. I have to
Okay.
solve the equation. Whenever I'm trying to find the x-intercepts, I have to set the function equal to 0. But I did not write this yet. We were just discussing which situation we are looking at.
Okay.
Because if the situation is this, and if this number is negative, I'm not going to find the solutions. I'm not going to waste my time. I will say no solutions. if the y coordinate is 0, I'm not gonna waste my time. I'm gonna say the vertex is also the x-intercept. But if the y coordinate, which gives us the maximum in this case, is a positive number, it's this case, and I have to find these 2 points. I don't have them yet. So it was just a discussion, like a side commentary, right? So because I will always look at the vertex and say, x-intercepts, oh yeah, I have to determine them. If I have 0, I'm going to say the x-intercept is -2. If I have -3 in this case, I'm going to say no x-intercepts and move on. Right? Is that clear? This was just a parenthesis if you want. This is like a side discussion. Since it's this third case, I have to determine them and I have to solve this equation. And y is the function. Y is, what was it? X squared, -x squared minus 4x minus 3 equals 0. And that's how I find these 2 points. Is that clear? Yes, everyone? Are you with me? Yes? Okay. Stop me if it's not clear, please. Okay, so obviously, what do you think I'm going to do before I solve this equation? Right, but since it's an equation, I will multiply both sides by -1. If you remember, I personally refuse to solve a quadratic equation with a negative leading coefficient. And it will not affect anything.
Is this still number 4 or we on step 5?
We are finding the x-intercepts. We have not found the x-intercepts. We are looking for 2 x-intercepts. Better? So I will factor into x plus 1 and x plus 3. And I find 2 x-intercepts. And those x-intercepts are excellent. Thank you, Michelle. -1, 0, -3, 0. Excellent. Number 5. So what do we know so far? We know domain, we know the vertex, we know the shape, and we know the x-intercepts. The next step would be, what do you think? Of course, the very good. Y-intercept, it has to be only 1. And how do I find it? For any function, how do I find the y-intercept? F of 0. So let's do f of 0 together. So look at the function and tell me how much is f of 0. 0, 0. Very good. So -3, 0, -3.
So just substitute, right?
Yes. Is that okay? So it's right here. Right here. 0, 0. These 2 are gone because they're 0.
I don't know, I just gotta write it down because I can't just put have it. So I'm just writing it down.
Okay,
So I know
very good.
how I got the answer.
Yes. Yeah, I mean, f of 0 is, we replace x by 0. Are you with me, everyone? Number 6. Axis of symmetry. We are not talking about other even functions. So this function has a maximum. This is the maximum or the vertex that gives the maximum. This line is the axis of symmetry. It's a vertical line through -2, 1. Can anyone give us this vertical line? What should it be? If the point that is coming through, -2. This is the y value.
Oh, yeah.
Yes. X equals -2 indeed. X equals -2 is this line. Excellent. Step 7 and step 8. Did we agree that this function has a max or a min? One more time. Good. So then max value is not the x-coordinate. The x-coordinate is the position, and it gives us also the axis of symmetry. Exactly. Why max value is?
1.
Indeed. Awesome. Last step, range. And if you want to say, Wait a minute, you haven't even graphed the function. You're asking us for the range. Yes, because we already know the range. By this time, we have the graph in our heads. So can anyone give us the range?
Negative.
Excellent. And we haven't even graphed it yet. Well done. And now let's put everything together and graph.
How's a negative infinity in that at 2 the one again?
Where does the 2 come from? Which 2 are we talking?
For the max. For the vertex, right?
How did you pick 2? Is that better?
No.
So look at this graph. From negative infinity till the maximum. You just told me the maximum is 1, right?
Right.
So from negative infinity to 1.
Is it because it has arrows? Like...
Yes, of course. Yes, very good point. I see. Very good point. Yes, of course. The function goes on forever. Good point. Good. So we start by graphing. We start the graph of the function by plotting the vertex. One more time, the vertex is? Good. We continue by graphing the axis of symmetry. It is not part of the graph. Do not graph it as a solid curve or solid line. It will only help us keep the graph in shape. Then we have the X-intercepts, -1, 0, -3, 0. Make sure that these are symmetric, because this is the axis of symmetry. And then we have 0, -3. Please connect and extend. Do not make it too sharp at the origin, at the vertex, I meant to say. And at the same time, try to make it as symmetric as possible with respect to the line x equals -2. Always write on the graph what we graphed somewhere. On the left, on the right, underneath, above, whatever you want. But we have to state what we graphed. We have to put the function name there, or the expression. Any questions?
Where did you know?
Say it again.
Where did you know?
Yes. So do we understand all steps? Yes? Okay, here's another. And this time I would like to look at the other possibility. So let's say f of x equals x plus 4 everything squared minus 4. Okay. Well, we have no secrets, or this function has no secrets. Why? Because I know transformations. What is the base function here? X squared is the base function. Where does it? Where do I shift it now? To the left 4, and then what do I do now? What is the vertex? We haven't even graphed it. We haven't wrote anything. Exactly. Does it have a minimum or a maximum? A minimum, right? So we went to your left 4, right? And down 4. So the vertex, in this case, for this form, see the difference between these two forms? This is expanded. This is expanded. But this one has the completed square. So I will still start by writing the domain. Can anyone give us the domain? Of course. In number 2, I need the shape. Minimum, very good. Number 3, the vertex. In this case, the vertex does not need any calculations. All I have to do is think in terms of transformations, and I figure it out, and I don't have to do anything. So can anyone give us the vertex one more time? So it goes to the left 4, so it must be -4. And it goes down 4, which must be negative. Oh, what did I write? What is this?
You okay?
I think so. I hope so. Am I making sense? Most of the time? Then I should be okay. Okay. Is that clear? One more time. Let's do this one more time. So what is the formula? I just don't want to just give a formula, right? So if we have f of x, which is ax plus h squared minus plus k. It's a very good question. Am I okay? It's a very good question.
You feel okay?
I hope I'm okay. Okay, so this is the general formula, right? Where the vertex has nothing to do with the circle, if you remember last time I said that. So this is the vertex. But remember, there is a negative in here. So x plus 4 shifts the graph 4 to the left, and then 4 down. That's why the vertex is -4, comma, -4.
So if you're solving it, basically you would say x.
Yes, you will have,
-4,
yes, you
or
will write x minus -4, exactly, squared and -4, correct. And that's how you get the -4, comma, -4. Now number 5, I want to think and see from the very beginning if it has X-intercepts. Because, yes, Danny?
You mean step 4, not step 5?
As I said, I'm not sure. I'm not sure. Totally disconnected. Well, from now on, after 3, 5 is next.
Okay.
Moving forward, just make sure. Yeah. Okay, so does this function have X-intercepts? Because I don't want to waste my time.
Yes.
Yes, because the minimum value is negative. Exactly. If the minimum value were positive, would I waste my time looking for X-intercepts? If the minimum value were 0, that would have been the vertex as well. But since the minimum value is negative, the function must cross the x-axis twice. Do you agree with that? Let's do this one more time. X squared, 4 to your left, and then down. Does it cross the x-axis or not? In 2 different points. Because the y-coordinate of the vertex is negative. So yes, they exist. How do I find them? Exactly, like always. Very good. X plus 4, everything squared minus 4 equals 0. Now what? What type of equation is this? And if you say quadratic, then I'm going to say excellent. And now please tell me which of those 4 methods. We know 4 methods of solving quadratic equations. Which one